Welcome to this presentation and demo on LMI 3D machine vision with universal robot integration. Over the next 15 minutes, we're going to show you how to create a simple pick-and-place application using an LMI 3D machine vision system and a UR robot. So let me explain my hardware setup first. I'm using a UR5E robot with the latest software and a Gocator 2350 line profiler. Now everything I'm going to show you we've done with a Gocator 2500 series or the largest member in the line profiler family, the Gocator 2490. I have everything mounted using a custom bracket. And you can see that here. LMI offers a couple of different brackets. Generally, customers machine their own. Here are examples of some other brackets that we've used with our smaller and larger field of view sensors. And of course, you need to accommodate a gripper if you're going to be doing pick-and-place operations. As far as parts go, I'm going to start off looking at balls for doing my calibration, my hand-eye calibration, and these can really be anything. You can use a high-accuracy ball bar, or in this case, I'm just using two spheres positioned on a flat plane. And then later, when we do the pick-and-place part, I'm going to try to pick up a 3D block with different surfaces on it. For software, I'm going to be using a VNC viewer to show my UR teach pendant. So here's what that looks like. And I can interact through this interface just as if I was holding the teach pendant in my hand. For interacting with the Gocator, I'm going to be using just a browser window to change tools and settings inside the Gocator. Actually, a lot of this I'm going to be doing through the UR robot. If we look back at the UR robot, I have a UR cap loaded in my UR robot. Here's that UR cap. I have one for my gripper and one for the Gocator. What this gives me access to are a few different functions, including hand-eye calibration routine, and then in my program, various functions like receive, scan, trigger, calibrate. We'll use a few of these in the program. But first, let me go through the hand-eye calibration. The purpose of the hand-eye calibration is to generate a transformation matrix between my 3D vision system coordinates and the UR robot coordinates. And I should point out that the UR cap is a plugin for the UR robot that allows communication with the Gocator. So it not only gives me these functions, it allows the UR robot to talk to the Gocator, send commands, and receive results. So in setting up the hand-eye calibration, we walk through this wizard, select the IP address of our 3D system, hit connect, and then we're going to download a special job into the Gocator for doing this hand-eye calibration. If everything goes well, it tells me setup job completed successfully, and now on my Gocator there should be a new job. Under jobs, before I had new and then a pick-and-place job. If I refresh this window, I should see a new job called Go Robot Calib. There it is. I can load that and check the settings. And I'm ready to go. There's really just one tool in this job file, and that's a surface ball bar tool, which is going to look for two spheres and a plane, and that's going to be used by the calibration routine from the UR robot. All right, so now we can go back to the robot and set up our calibration routine. We're going to have an empty program with a Gocator calibrate tool, specify the IP address, job file, and we can increase our surface length, set some of these scan settings. And that's it. Now we can run this, and you'll see on the robot, some motion. The UR robot is going to move our Gocator through 8 different scans, 8 different angles and positions, and we'll see the image update back in our browser window. And with every scan, the surface ball bar tool gets run, and the results get sent over to the robot. And if everything goes well, we'll generate a transformation matrix that'll be used to convert from one device's space coordinate system into another device's. And it looks like everything went well on our robot. We would see errors if it didn't. So now the hand-eye calibration is done. We can go ahead and build a program to do the pick and place operation. So let me go ahead and put the correct part in front of my sensor and then load the right job on my Gocator. Before we had the Go Robot Calib job, now I'm going to load a job called UR block. And this job is going to have a few tools that look for a block and find the center of it, as well as the roll, pitch, yaw to communicate to our robot. On the robot side, we've disabled the calibrate tool, but we're going to need to add a few other tools, including Gocator Connect, and here's where we load that calibration matrix that was the result of our hand-eye calibration. In our robot program, we'll start with a move to home. We can define this current location as our home. And then we'll execute a scan. And we can go ahead and run this just so we get data into our Gocator. The program isn't completed, but we can execute it with what we have now. You'll see the robot moved the Gocator through one scan. That was it. And on our Gocator, we now have new data. Instead of ball bar, we see a block, and the tools find that block and measure the XYZ roll, pitch, yaw of it. So we can communicate this information to the robot and guide the gripper to pick up our object. We have a little bit more work on the robot side. After a scan, we need to receive the information. So we're going to set up a Gocator receive tool. The variable is going to be our block. Now the measurement ID is whatever ID we use on the Gocator. So we can check that in our output. We're going to send the XYZ roll, pitch, yaw starting at ID 7. And instead of a single measurement, we're actually communicating a bit more, the XYZ RPY. After we receive that information, we want to move to it. So we're going to set up another move. And our waypoint isn't going to be a fixed position, it's going to be a variable position, it's going to be that block. And let's add a weight at the end. One second. And we should be able to run this. The program is going to be incomplete because I'm not activating my gripper, and I'm just moving the gripper to the top of the block. I set my TCP, my tool center point, to be the top or the end of the gripper. In fact, if I go to my move area, I can move it, and you can see the gripper is moving around this point at the end of my TCP. All right, let's see if this works. Go to our program. We can have it loop forever. Let's go ahead and run it. All right, so far so good. We've got the Gocator scanning our block. The program finds the block, sends that information to the UR robot, and guides the gripper to the correct location. Let's go ahead and finish up this program by adding some gripper moves as well. So before we execute our move, I'm actually going to move that point 1 centimeter down so that instead of moving to the top of the block, we move down a little bit. That way we can pick the block up. All right, that should be good. Let's go ahead and run this now. So the program works. We can pick this block up in any position and orientation, guide the robot down at the right angle. I should point out that our documentation on this is excellent. Here's how you access our documentation. There's a full section on UR integration, which talks about the UR cat, the hand-eye calibration, and how to set up a program similar to what we set up here doing pick and place. So thank you for attending this presentation and demo of LMI 3D Vision with UR robots.